It's a fairly recent technique that came along about the same time as Agile programming came along. And in fact, they go very well together. I would say even something stronger. I would say to really do Agile properly, you have to do test-driven development. What is test-driven development? It's really a strategy for interleaving code development with automated test development. Okay? So this is different from the traditional view that you write the code and then you toss it over a fence to somebody to test it. It's different in two respects. One is that you're actually writing tests while you're writing code. In fact, even stronger. You are writing tests sometimes before you write the code. And that is strange on the face of it. The other thing is it's really emphasizing automated test development. This is not about clicking buttons kind of testing. This is about writing code, developing test infrastructure while you are developing code. So it's really a task that the developer is best suited to. And actually, it's not so far from what I suspect most programmers do. And this is what I'll try to demonstrate today. Is while you're writing code, sometimes you have to try out your code to be able to make progress, to actually understand the fine points of what you need to do next. You have to see a concrete data set. You have to run a test. Very often, that happens by the developer setting up their workstation, their database, whatever, and doing some manual steps to get to the point where they can answer the question, well, what exact command I should run here? What exactly is in the database at this point? What should I do? Okay? Except that very often that happens manually, and it's a setup that gets thrown away once this feature is implemented, once this project is deployed. And that's a pity, because we want to save that. That's needed when you're going to be maintaining the code, refactoring the code later. Okay. And very importantly and strangely, again, is that sometimes we're going to write the test before writing the code, and that has big benefits. So let's go through the typical steps of test-driven development. So let's say you are in the middle of developing your project, and you are given a new task, a new feature to implement. So how do you start? So normally, you'd have to explore a little bit to figure out more concretely how do you implement this feature. The specification may be given to you, but how to actually do it, it's not clear. So you have to look at the schemas of the database, perhaps even a concrete data set. Okay? And all I'm saying is now we're going to be writing code to do this kind of setting up an environment, as opposed to just doing it manually. Okay? Think of it as you're going to be writing the setup part of a future test. And of course, when you write the setup part, you have to write the teardown, if appropriate, if you're setting up something that needs to be cleaned up. Okay, so now you have the fixture in place, the database, the tables in place. In test-driven development, you think first, before you even think of how the code actually does, you would think more of how the code will be used. Right? So again, you're coming from the user of the code, and so best way to do this is to think about what is going to be the name of my method, what arguments should I pass, what arguments make sense to pass for the user, before you even think what arguments make sense to receive for the method. Okay? This is very important because this will result typically in APIs that are more user-friendly. And when I talk user, it's not the end user of your user interface. It's the user of your library, the user of your code. The other modules are going to be calling to the code. Because that's how we should be writing APIs, not reflecting what's hard to do in the middle of the method, but reflecting how they should be used most naturally. And you do that by thinking first, how do you invoke the code? Before you even write the code. Okay? So essentially what you have written so far is the large part of the test. You've written the setup of the test and you've written the invoking of your method. You haven't yet written the assertions that the method has worked. Because perhaps at this point those are not extremely clear, especially when you are dealing with fine details about how your data should be looking. But now you actually start writing the task A. You've written much of the test, now you actually write the task A. And the good thing is that while you're writing task A, as you're making progress, you can just click a button on your IDE to run this test that you have prepared. And it immediately brings the execution to the point where you're actually writing code with a concrete data set. Makes it a lot easier to see, I see how the data looks. Now I need to take those things and sort them or add them or something. Okay? And you keep refining this. And because you've automated all the setup, you just can get here very quickly, can iterate very quickly. As opposed to if you've let all those previous steps manually, that requires you to manually start up the database, clean up the data, all that. It's going to be a lot harder to iterate. And once you actually finish the code and you're happy, then you can actually finish the part of the test that does the assertions that the code has worked correctly. Sometimes you can do those assertions early on if the specification is very clear of what the output should be. But sometimes the tests depend so much on the intricacies of the data that it's hard to kind of mentally predict what the output is going to be precisely. So that's why sometimes I write those assertions after I'm done writing the test. But I trust them because I've just written this code. I've just traced through it. So I know what it should be. So I write the assertions now. And I have now written my feature, and I have the test ready for the future, okay? And then you keep repeating from step 1 or 2. Give me another feature or a bug, I'll write the test. I'm run the debugger, make sure that the test really brings me to the place where I need to be debugging with the data that actually reproduces the scenario I'm debugging. And then I fix the code, and then I finish writing the test. Okay, any questions about the general steps? How many of you have written tests before writing code? Okay, so a few of you are already converts. Good. So test-driven development fits very well with agile development because it's really, you write some code, you try it out, and when I say try it out, it's not manual. So automate this trying it out. That's a test. Okay? And then learn how to improve it. And what is not clear yet is the huge benefit you will have in the future for the investment that you put in the test. But I do want to stress that even if you don't think about the future, there are many tasks for which the fact that you can iterate on this, on refining the code very quickly, since you have invested in infrastructure, it's a great feature. So this reminds me of one feature I had to implement once, was something that had to work with an installer. Okay, the kind of installers that you use to install software on, or plugins in the browser. It was a browser plugin. And if you remember, to install a browser plugin, you have to click, yes, I accept it, yes, I do that. So by the time the installer gets to run, there's five clicks and a few page reloads that you have to do. Okay? So I took the time to actually invest in writing, to automate all those steps, to get the browser to my installer. Okay? And it's painful because automated user interface, it's painful. So it might have taken me half a day, which seems like a long time for a feature that maybe by itself takes another half a day. Okay? But the ability to then very quickly just press a button and have all those clicks done and get me to the point where I need to be refining my code. That, I must have used that tens of times. So I actually think this investment paid off in the initial development. Forget the refactor that comes later and maintenance. Now, in my experience, you don't really believe in test-driven development until you see it. Some of you won't believe even after you see it. Hopefully you'll believe once you'll be suffering through maintaining a big project without tests. So the best way to do this, to teach test-driven development, is to actually go through an example. And the inspiration for this has been this book written by Kent Beck, which is the same guy who developed XUnit, the family of test interfaces, of test frameworks, and test-driven development, and a lot of agile technologies. So I'll pass this book through the audience for you to kind of browse through it. And it really goes to developing a very small project, but emphasizing what kind of tests you write at various steps. So I'll just pass this along so you take a look. And while we are here, I brought to you the other book I mentioned last time. This is a thicker book. This is about XUnit, using the unit testing frameworks effectively. But it goes, it's not just unit testing. Even though the name of the framework is XUnit, the concepts are used for functional tests and integration tests, perhaps stopping short of system tests. So this book kind of goes to many of those patterns that we'll be covering. We covered last lecture, and we'll cover in 2 more lectures. So I'll pass this along as well. So this is one of those books that is actually worth having around in your library. Okay, so what will I do? Instead of just sitting here and saying you should eat broccoli and stuff like that you don't believe, I will actually sit down and show you how I would use test-driven development for developing a small script, the kind of script that once in a while we'll feel the need that to develop. The one that I picked is to write a simple program in Python that scans a Git repository and collects the list of bugs that were fixed recently, let's say, and how many lines of code each one required to fix. It's a small kind of report based on Git. Okay, so I'll call this system Bugaton. And it's actually going to be about a 100-line program in the end, at the end of the day. I will show you, I broke the development in 26 snapshots, which they are all described in this document, and I will show them to you. One thing that we will do is we will look at different snapshots, and I will point out to you what I have changed in each step and why. And you will see that at some point we change tests, at some point we change code. At the end of the day, it's going to be 100 lines of code and 130 lines of test, just to give you a heads up. And you will need to actually go through these steps, or at least some of them, for the quiz that we're preparing for next week. Okay. I'm curious, did any of you try to download this and run this on your machine? Does it work? Are all the pieces there? A resounding yes. Okay. Is what?
It's saying it can be either all yes or all no.
Yeah, and if it's no, I'm not sure whether the pieces are not there or... Anyway, I'm sure you'll let me know if something is missing. Probably just a few hours before the quiz is due, but let's move on. Okay. So let me ask at least the question whether it's clear what this program is supposed to do. Well, actually, I moved a little bit too fast because I have, I think, one more slide that should answer precisely this question. So I'm still in the specification mode. This is what I would like my program to do. If I run bugaton.py in my local working directory where I have the Git repo, it's going to print a table like this, say bug or issue number 7673, 182 lines changed. And this includes lines added and deleted. That's how Git kind of counts. And so on. Okay? And you may actually wonder, where do I get this information? Well, the number of lines changed, Git knows this, because Git keeps diffs between versions. But how would Git know what bug was fixed when? And that's part of the conventions that most development teams have. For example, this is the Git repository used by the Python interpreter developers. Okay? So Python is an open source project, has a Git repository and I just grabbed it, and it's included in the tarball that you're downloading. Actually, it's a fake, it's a replica, much smaller, but enough for our purposes. And the Python developers have these conventions that when they're making a change to the code that is whose purpose is to fix an issue, they will reference the issue in a particular syntax like this that computers actually will recognize. And this syntax will hashtag number is actually the same syntax that GitHub uses. So in GitHub, you can open issues, and then as long as your commit message contains hashtag a number that matches an issue number in your Git repository, you're going to see in the UI a cross-reference. In the issue, there's going to be a little window that says, here's a commit that refers to it, and in the commit, you can click on it and takes you to the issue. Very convenient. Okay? So Git will also, if you give it a short stab argument to the log command, it will print these numbers here, how many insertions and deletions, and how many files will change. So we're going to get these numbers, add them up, and produce this 182, and we get the issue number from here. Okay? So this is really what we're doing. It's a quick hack that we're going to manage to stretch for an hour. So the flow of the code is going to be, we actually will use the git command to interpret the Git repo. There's no purpose, no point in us trying to do that. So we will invoke, our program will invoke Git, and to get the logs in a text file. And essentially, the bulk of our program will be processing that text file, the output of Git log. We'll first split the log into commits, and then for each commit, we'll parse it to go find the issue number, lines added, lines deleted, add them up, and print the report. Right? As simple as that. And my point is that even for something as simple as that, I bet that nobody here can write it from scratch without mistakes, without actually trying it out in the middle. Because there's things like exactly what command you pass to Git, exactly what matching the regular expressions you use. You could be off easily. It's not a matter of being smart or not. You just can't. You have to try it out. Okay? So what I'm going to do is this trying out, I'm going to make it more systematic and turn it into tests, such that we have them afterwards. Okay, now it's time to actually switch to the code. So version 1 of the code, I've just kind of get it started. Actually, even before this, probably what I did, I ran Git by hand a few times. Like, okay, the information is here. Once I figure out how should I run Git, I actually wrote code to do this running, so that I don't have to do manual testing. And this is the function get git log that I wrote in my Python file. There's no point in trying to understand right now. I see what you're pointing out. What happens here? I'm looking at code that you don't see. Okay, so now we all see the same thing. So I wrote this function get git log, which is going to invoke Git, tell Git to save the output to a file, and then read the file in. Okay, so the first line is just a way to find the exact path to my Python Git repo, which I included. Then it's creating the name of the output file in the same directory called out.txt. And then this is really how in Python you invoke commands. I change to the Git repo and run this command, git log -10, which gives me the last 10 commits. And I save them to a file, and then I read the file in, I delete the file, and return the text. Okay, so we're not going to touch this. This function will stay like this to the end of our project, because we're not going to do anything with it. The bulk of our project is actually processing this file. So let's look at what I wrote. I wrote some skeleton for my project. In the main function, I wrote a call to this helper function, get parsed git commits, whose purpose is to go get the log file and then split it into commits and then parse each commit. I've decided the name of the function so far. I don't quite know what the commits will be, and I don't know yet what I'll do later with them. So for this function, first thing it's calling this get git log, and then prints the log. Okay, so this is the first step you're doing, just to make sure that you're invoking git correctly. So we'll get in the habit of running these. And you run them by simply invoking Bugaton .01.py, and you see that it prints something that looks like our commits, log messages, okay? And the information is in there. We just have to go grab it. So this is skeleton number 1. But I want to point out, we're already testing. We're already running git to make sure it works as we expect, as we need it for our project. So then we move on to version 2 of the code. And one thing actually will help you at home is to run diffs between 0.1 and 0.02 to see exactly what has changed. Most of these steps are very small. What I've done in this step here was to start writing the code for get parse git commit. So in step 1, all I had is this get git log and print the log. Now I actually sat down and wrote the code for parsing. And this is code that's actually simple code, but I always get it wrong, slightly. And this has actually several bugs, not all of which I put intentionally initially. So I'll just kind of read it off to you to get an idea of what it does. So I split all the lines. I go line by line. If I see something that starts with the word commit and then a space, I know this is the beginning of a new commit. And I take all of the lines that I've accumulated in the current commit. This is how you join them together, and you put them all in all commit. So all commits is going to have one entry for every commit message. And every commit message is several lines, which I accumulate in current commit. So I keep accumulating lines in current commit, and when I reach the next commit, I save the current commit in all commits. I reset current commit and keep going. And at the end, because I don't yet have the code to actually do something with them, I just print them so that I can look at them. Because for now, we're doing testing, but it's actually half manual testing. The exercise part is automatic. The validation is visual for now. Any questions so far? Okay, now let's run it. Okay, so now you see it prints what looks like 10 commits, perhaps, from Python. But I already realized that it's pretty annoying to have to validate this visually. So now I'm going to start writing some automatic validation code. And the first thing, really a poor man's validation, all I did, I added these 2 lines. I added an assert statement in my code to check that I have 10 commits, because I called git and told git, give me 10 commits. And after I do all this mess here, I should end up with 10 entries in my whole commits. And now I'm sure you know that this is going to fail, so otherwise it wouldn't be fit for the lecture. So I run git 3, and it fails. And this is how my code fails. If you use Python, then this you've seen this before. What I want to say now is we have an automated test. We have automated already the exercise part, go get commits. We have prepared this Python repo that's part of the fixture. And now we've written the validation part. So we kind of close the circle, and we have a full automated test. Question?
Can you talk about again how do you come up with the number 10?
How did I come up with number 10? I just picked a number that seemed not too small, not too big.
No, like, do you find that number 10 from,
Oh.
you just like pick a number?
Yeah, okay, sorry. I misunderstood your question. in my code, if you've looked at the code here in get log, I told Git to give me 10 commits. Okay, so I expect to get 10 things back. Thank you for the question. Okay, I was assuming that people remember that, but if you don't get lost. Ask me. This is all easy stuff. The details may be tricky. So, okay. So, point one, we have an automated test. It's not a very good test. So we're going to work improving it. The first thing that is actually not very good is the error message. Okay, it's an awful error message. It tells you that this was not 10. It could be 9. It could be 11. If it's 9, we missed a commit. If it's 11, we probably have one extra. If it's 0, we miss them all. Okay, we don't even know how bad this is. So remember what we do here? This was covered in the last lecture. Assert equals. Right. So far we use this built-in assert in Python, which is the only thing you can use pretty much in any Python project anywhere because it's built in the language. Okay, but actually we can't yet go to assert equals for an interesting reason. But we can use this assert better, and that's in Bugaton 4. Look what I've done. The assert statement in Python takes not just an expression. You can put a comma and put an error message. Okay, and in the error message, I'm writing down information that I know I will need to debug this. Specifically, how many commits are there, and how many do you think there are? Instead of 10. How far do you think I am from? 9. Good guess. Okay, so I'm clearly missing a commit. I don't know yet exactly why, but okay. So for now, what I wanted to say is, so what I've done here is from step this was 4. From step 3 to 4, I've done something that maybe is counterintuitive. I had found a bug. Instead of rushing to fix the bug, I actually spend more time strengthening my test infrastructure, adding error messages, and you see we'll do more of this in the early stages of the project. And this is one way in which people kind of discard test-driven development, because you have to invest quite a bit in the early stages of the project. And the early stages of the project are interesting stages. First, you're full of excitement. You want to see these things moving and kicking. Okay, so you don't feel like stepping back and writing messages on assertions which will never trigger anymore once you fix all the bugs. Okay, so it feels strange. Second is you think, well, this is a very quick project. I'll finish this in an hour. So why should I spend time for this? Well, the truth is you won't finish it in an hour, and if it's really useful, you'll be working on it a year down the road as well. Okay, so it's worth investing. And third, if you don't make these investments, small investments, while the project is small, if you wait until too late, it's going to be overwhelming. And in fact, there's another textbook just as big as that one that says about how do you take a project that doesn't have tests and try to put some tests in it such that you can refactor it. Okay, so don't get there. Try to invest this early. Okay, so now this is about as good as the assert gets, and in fact I could go in with my debugger, put a breakpoint, and figure out exactly what the bug is, but I won't do that. I will bite the bullet and say I need to really invest some more in tests. So far, this is not very good because this assert is in production code. I cannot have an assert like this in the production code because in production code, hopefully, this number will vary. Okay, and I don't even want to start putting more asserts in there. So I want to now separate testing code from production code. Put the asserts in testing code and keep the production code clean. So this is what I'm doing in step 5. And this is, in terms of code written, it's a bigger step. Okay? But it's something that I do in all of my projects, so I go and copy paste this boilerplate into the project. And this is actually my style for small hacks when I do tests for very small projects. What I do, first I copy this part from another project. What this does, essentially, if the first argument to my script is --test, then it runs the script in testing mode. And it invokes this unit test built-in library in Python. And what this does, which I also import here, this unit test library, when you invoke it, it will go through your file and find everything, all the classes that derive from unit test.testcase. And we'll go into that class and find all the methods whose names start with test, and we'll run them. If you don't have this argument, you just fall back into your production code. Okay? So if you have a one-file script, I typically do this. Once you go to a bigger project and you know it's going to be multiple files, then I invest even more, and I have separate test files, which I name with __ tests, put them in a separate directory, and I have another boilerplate that runs them from that separate directory. Okay? So that's a 15-minute, 30-minute investment that you know will stay with you. So let's look a little bit at the test code. Okay? So this is for Python. Our spec for Ruby, very similar in principle. The actual keywords and code might be a little bit different. So the tests are going to be a bunch of classes that inherit from test case, and inside the classes we have these tests. For now, what I have done, I'm invoking directly this git parse git commits function in my code. I don't have any assertions in my test yet. I'm still using the assertion from the production code, because for now, all I'm doing, I'm trying out the test framework, making sure. Okay, so I run 0.5. Okay, so this is the program exactly as before, the same behavior as before. The assertion fails, but now I can run it with --test. And in fact, for the rest of the lecture, we'll be running tests. So all of our scripts will be run with --test. Okay? And if you run it, it fails in a very similar way. Actually, even the projector fails in this case. Yeah. Looks like it's time for a break. Now let's take a couple of minutes break. I need to fix this, okay? So we'll talk later. Yes, thank you. Is there anybody who maybe came in late, didn't see the Ken Beck's test-driven development, for example? So I did a couple of interviews for Conviva yesterday. This is the problem I asked.
Are you happy with the answers you got?
One yes, one no. It's a very simple problem. I've discovered that there's no point in asking hard problems in an interview because you can get a lot of information out of a very simple problem. Do you understand the problem? Are we? We just started to separate the code from the tests. But this is still pretty bad testing because, actually, just when, remember it crashed when I was showing you how the test failed and then the projector failed. This is the one point I want to make. All I've done is I've changed the way I'm invoking my code. Before I invoked it from this main, which went on and blew up an assertion. Now I'm invoking it by way of this test framework, which by itself goes, tabulates all the test cases, all the tests, and starts running them one by one. There's only one here, but you already see some benefit from this. We get all of this nicer output where it separates all the failures by test. It counts how many failures, tells you how long the test runs, so you're only going to get some benefit from the test. But the failure itself, it's the same one as before. Okay, and this is what we're going to be working on next. So moving to number 6. So number 6, I'm actually now starting to write tests. Okay, so what I have done is first I realized that my code so far runs git, gets the output from git and tries to parse it, and then there's a bug, which is why the assertion fails. This is bad for many reasons. First, it's a very heavy test. I mean, I'm running an external command, then git goes to harvest stuff from the database only to find a bug in parsing. There should be a better test for that, one that kind of bypasses the whole git thing. The other thing that's not good is that kind of tests against the live Git repo. Okay, so tomorrow the test is going to run a little bit different because somebody has pushed a commit to the repo. You don't want tests, or if you want tests like this against a live repo, they have to be very unambitious in terms of what they assert, because you cannot assert that a certain bug will appear in the output because the repo changes. So for all these reasons, we want to make tests that don't depend on the outside collaborators. So what I'm doing, and this is a very common technique, I copy and paste the output from my git log, and I put it in the test. So I write this string, git out1, which is really one of the commits, and then I'm going to pass it. Well, now I don't have a function to take this input because my only function was get git logs, which was going and invoking git. So I'm thinking now of writing a function that will take the output of git and split it into a list of outputs, one per commit. Okay, and in this case, there should be one commit. So I'm going to write the assert 1 equals len of s. And now, what do you think happens if I run this? Well, actually, maybe it's hard for you to tell. But I have not yet written this function. So if I run it, 6, the test fails saying that this function is not defined. That's okay. This is just an instance when you have actually started thinking about the structure of the code from the perspective of invoking it. So I've This gave me an opportunity to think about what is the input-output behavior of this function, what is a good name for the function from the perspective of the caller, but I haven't yet written it. So this is what I'm going to do in step 7. And this is a cool one. Okay. So in step 7, sorry, I'm a bit confused here. Oh yes, what I want to show you is how to write this function. Okay, let me say it again. This is how our code looked before. It was going to run git and then immediately parsing the output. So this function mixes up interaction with the collaborators, which is git, with the actual work that we do. Well, we don't need to test git. We trust git works. Okay, this is where the bug is going to be, and all this stuff that we wrote. But we mixed up this stuff alongside with invoking the collaborator. So we have to hoist this out. We have to take this part of the code, separate it in its own method, which we can invoke independently of running Git. Okay, you get that? Okay, so this is a very common technique that you do when testing. It's called extract method. And especially if you wrote this code before having testing in mind, you will end up mixing logic like this with interaction with collaborators. So I want to take all of this code and put it in its own function. How would you do this? By hand.
We could, for instance, put a parameter in the function definition, git log, and then have another function call this function with the git log as an argument.
Yes, you have the right idea, but I'm going to do it a little bit differently. I'm going to keep this function the way it is because this is the entry point, and the first thing it does, it's going to kill Git. But I'm going to write a helper function that does this part. Okay? Now, here's some magic. You might have noticed that I'm using an IDE here as opposed to a text editor, and this is a big thing that I believe in, but I know very few people actually do. Use IDEs as opposed to plain text editors, because an IDE allows you to edit, but it also understands the language. And one thing it can do, I have to get out of this presentation mode for a bit. Okay, I'm gonna tell this IDE to extract the code into its own method. So I'm gonna select it. Say I want this code in its own method. Go to refactor, extract method. It's going to analyze the code and says, how do you want to call this? And according to my plan here, this is called split git log message. And it says, okay, I'm going to call a git split log message. And the IDE has analyzed the code and figured out that the only thing it needs from the host method is git log, and asks me to validate. So this is going to take one parameter called git log. Because if you look through the code, it's all self-contained except it needs this git log to come from the host method. Okay? And then it also figured out that the only variable it computes is called all commits. So that's the only output variable. And I said, okay, done. Look, it has created this method with exactly the code. It has put the parameter there and made it return all commits, and has replaced all the previous code with this line. Okay? Magic. Okay? Try to get Vim to do this. Again, so you can get free licenses as students to this site. This is called PyCharm, and there's a sibling one called RubyMine. They're amazing. Okay, what they do for Python and
IntelliJ as well for Java.
IntelliJ is the same family.
Yeah.
Same family of IDEs. Use IDEs when you program. Write emails with Vim. Okay, so this is going to be a common theme in our refactoring, which I'll get back to in a couple of lectures. We're going to have a notion of something called humble methods. Humble, it's kind of tries to be a nice way of saying stupid. This is going to be a humble method because it's going to be more like a script. Invoke that, invoke that, invoke that. It's going to be very hard to test these humble methods because it invokes these external collaborators that are heavy, maybe take a long time. But it doesn't have any interesting logic. There's a little opportunity to screw up in this method. So it deserves less testing. The stuff that deserves testing, where you have all the ifs and the loops and such, okay, that should be methods that do not have collaborators. They're more standalone. And this you're going to test a lot. So it's very common. So if I now run the code, it's going to do a little bit better than before because I actually have defined this split log message. You might have noticed in the previous slide that there was a squiggle under this in 05. Sorry, I'm not. Okay, so let me run it. 07. It's going to do a little bit better, but it fails with this assert, which now it's time to, again, the same trick. This assert is a bad assert. We'll have to fix it. So the way I fix it now, I can do much better than before. Because before, these asserts were in production code, so all I could use is the built-in assert. Now I can use the testing libraries asserts. And you can write this assert equals. Okay, and there's a large collection. If I put here dot assert, look at the pie chart tells me all the asserts that I can use. Okay? So in fact, code completion, it's a big feature. So now if you run the test, this is 8, I believe. Now it starts to print something more interesting. 1 is not equal to 0. I use the convention that in an assert equals, the first argument is the expected value always. So then I know how to interpret this, that I'm expecting 1 and I'm getting 0. So my parsing code has a problem that it's dropping. In this case, it dropped all, but maybe it's dropping only one commit. Any questions so far? Yes.
You mentioned earlier that there was some kind of problem, like you didn't want to mix your logic with interacting with Git because it's live. But I noticed that even though you separate it into two methods, you're still getting like a live physical Git every time. Is that a problem? Like, should you memorize the data so that you don't have to?
That's a problem, but that's actually, you missed a point. This test split doesn't use Git anymore. It uses a pre-recorded output. You see, I put the output of the Git here, and then all I call is the split Git log message. So test split 1 doesn't use Git.
So you should use testing by like your own. You should use your own fixtures like that.
Yes, yes. And one theme that I will get to is when you have a bug that comes up in a test, try to write a smaller test. Because perhaps you have these tests that invoke multiple things and something breaks in the middle. And try to write a smaller test that fails in the same way. And yes, then you're going to have 2 tests that fail in the same way. And that's going to be common if you have a rich test suite. But you always go and attack the smallest test first when you have the same failure across many tests. It's really very, very useful. But here, yes, the whole purpose of this refactoring of interesting code was to be able to run it without invoking Git, to run it on this fixture. Okay, so in 9, I actually fixed the bug. It took me a while to figure out. I put, okay, the other thing you do, this is a debugger as well, this pie chart. So you put a breakpoint, run the test, and it stops there. The other thing, nice thing that it does, you right-click on a test and says, run this test in debug mode, or run it with test coverage, or all of this cool stuff. Okay, so the problem with my code was that as it was collecting the lines for every commit, when it encounters a new commit, it saves the previous commit, but I never saved the last commit I found out. Okay, so I've added this code now. If there's a last commit, append it as well to all commits. And now I rerun my test. This is 9, and the test passes. Okay, yeah, but I suspect that this is not not enough. So I'm going to write another assertion. Let's go back to my test. You see, this was the commit message. And I want split git log message to split it into, in this case, it's going to be one entry with all of this stuff because it's one commit. So one entry per commit. So instead of just verifying that I'm getting one entry, I'm going to also verify, and this is in version 10, I've added this line. I'm going to verify that the first entry of S contains Benjamin Peterson, which should be there because it's here. Okay, I run this test, 10, and the test fails. Okay, and the same thing again, false is not true. This is the assertion error. This is because we did not use the proper assertion. I've used this kind of assertion, assert true, and then you put here a complicated Boolean. Everything is fine if the Boolean is true, but if the Boolean is false, the failure doesn't tell you which way it fails. So I spent some time now to fix up this assertion, and this is how I wrote it. This is the first attempt. It's the same Boolean condition, except all of these assertions in XUnit take another argument. Let me put it like this. Another argument that's the error message to print when it fails. So this is going to help me if the assertion fails because it's saying that, well, I can't find Benjamin Peterson, and it's telling me exactly where it's trying to find it. So if you run 11, it says looking for Benjamin Peterson in, and all it has is this text commit. Okay, so now the error starts to be clear. As I'm splitting the commits, I'm losing most of them. Most of the content of the commit, I'm only getting the first line of the commit. But in fact, you can do even better in terms of the in terms of assertions. And this is another lesson I want to communicate to you. Sometimes all those tens of assertions that XUnit gives you are still not enough for your particular use case in your particular project. But then invest some time to write new assertions. So in this case, I wrote assert string contains because I'll be using this a lot, and it's going to print me that it's looking for needle in the haystack. And I know I'll be using this. In this case, it just was an investment because I don't want to have to write all that long assert from before. Okay, so let's move along. I have two more things to show you, and we'll get probably all the way to version 17. I'll leave the remaining 10 versions for you to try it at home. If I now I look at the code and find out how come I'm losing the lines. In here, I'm losing the lines for each commit except the first line. And I'm noticing that the place where I would be appending lines to the current commit, it's nested too deep inside this if. It only kicks in on the first line of the commit. Okay? So this should be unindented one level to here, which I do in version 13. So notice I moved it here. And if I run version 13, oh, now yes, so now I'm getting another kind of error. It's saying that it's expecting one, but it's getting two. So what happened? Before I was getting one commit, but it didn't have enough content. I fixed the content part, and now it broke another test. Now I'm getting two commits instead of one. Okay? So you debug some more, and you discover that there's going to be some empty, I forgot exactly what you discovered. Yes, the split function is going to return one empty line before the first commit. So it's going to create an empty commit. So in version 14, I added this thing here to strip all commits that would otherwise be the empty string. Okay? And now version 14, I think, all the tests pass. Out of curiosity, you can run the production code as well. It does something. I haven't done the part that actually prints the report. But what I want to show you next is, now you're at the stage where you set to implement some part of your project, you kept writing tests as you run into bugs, then as you fixed one of the tests, another test started failing. This is very common. Okay? I have some big projects that I worked on for years. A bug report comes in, I say, oh, I have an hour, let's sit down to fix it. I invariably break something else. Okay? Because I forgot all of these invariants I have maintained. So the tests keep me honest. Okay? I fix this, another test breaks. It takes me 2 or 3 iterations until everything fixes. I add another test for this particular bug, make sure I don't break it again. Because if a bug stayed for so long in your code, it's tricky, it's in a part of the code that's tricky, it's going to break again. Somebody's going to go clean up that code, and it's going to break. And then, in the life of an agile project, sometimes you realize that you could have done things better. So here, all of this mess, somebody looks at it and says, wow, you could do this in one line. Really? Yeah, you could use regular expressions. So in fact, what I'm doing here, I'm taking a long string and splitting it according to some pattern. Well, regular expression library has a splitter. You give it the separator, and it will split the lines. And look how it looks. It's in version 60. This is it. Actually, it's a 2-liner. Sorry. So I create a regular expression that says match commit at the beginning of a line, but have a multi-line match. Normally, a regular expression matches are line by line. This will go and find the first line that starts with commit, and we'll use that as a separator, and then say just split the log according to this commit, and return that. So one line instead of all that mess. That's great. But I would really not feel comfortable doing this if all my testing were manual, because I would have to go back and run all my tests. The good news here is that you can just run your tests, and if they work, then refactoring works. Well, actually, it turns out they don't work. In fact, 2 tests failed.
You skipped 15 on purpose?
Okay, semi-purpose. 15 added another test. Because I was at the point where all my tests passed and said, this can't be right, this can't be correct. So I thought of another angle, and I added another test with 2 commits. Okay, that still passed. So this is a good time for refactoring, is when all your tests pass. Do not refactor in the middle of implementing a feature. Presumably in the middle of implementing a feature, you have tests that fail, the test for that feature. Okay, you want to have all your tests in a clean state, because then you'll spot a refactoring regression. If you have 50 failures out of 300, and now you have 51 failures because of a regression bug, it'll be hard to spot. So I debug this, and I find out in version 17 that there's a little problem with this splitter. It's going to return an empty commit at the beginning. The same bug we had before, actually. When we're doing manual splitting, we're getting an extra commit at the beginning. Okay, it happens again with this automatic splitter. So it's good that we had tests for it. So we had to bring back some of that code to remove the first one. And I run 17, and all of my tests pass, and the code is nice and clean. So now it's time to commit. Okay, what do I have next? Which we won't cover here live in lecture.
So our quiz should be expected to be something that's based on what you covered here?
So the quiz for next week will involve last lecture, unit testing, some questions that covered in lectures. and some questions about test-driven development, and some very specific questions about this. I really want you to look at this code. Okay, so then if you see what happens in step 19 and so on, I start to add code for extracting the bug numbers, and invariably I have bugs in that code. And then I do another refactoring to separate out the portion of the code that's tricky and I want to test, and add more tests, and so on. At the end of the day, and again, there's a few more slides in my slide deck to kind of summarize this, but I'll just do it verbally. So you've seen the pattern. Okay, before you start the feature, you actually think about how to test it. That might tell you how to even structure your code, how to name functions, what kind of fixtures to have. A very common technique that I have when I have collaborators, I copy and paste output and put it in the test, such that I can feed that output, that fake output, to the rest of my test and do all my debugging like that. Once in a while, when you finish all the tests seem to pass, you run the production code, and you may find another bug. That means you don't have enough tests, and then you go back to the same process and add more tests. And the other thing that happens if you do it like this, you will see that I'll do test refactoring in maybe step 20 or so. I'm taking a big test and splitting it into smaller tests. Smaller tests are easier to debug. When they fail, it's very clear what the bug is because they exercise very little code. If you do all of this investment in test infrastructure, imagine down the road when a bug appears, some of the reports a bug. Okay? It's going to be very easy for you to create a new test for that bug because you have all of this testing code. You just have to figure out this bug is similar to which of the tests that you already have. You copy that setup for that test, maybe make some changes, add one more commit to our mock. This is a commit, a strange kind of commit message. It's very easy to copy and paste it, add a new test. Right? If you postpone adding tests until your program is big, it's going to be hard to add tests. It's going to be even overwhelming. So you're not going to do it. And this is a cycle that you'll never get out of. Okay? One thing about costs. One way to measure cost is just look at the lines of code, presuming that you type code at a certain speed. For this project, it's 80 lines of production code, 130 lines of test code. But that 130 lines is an overestimate because 70 lines are just copy and paste commits. Logic, which takes more to write, it's about the same size as the code. And that's pretty typical. You have to expect that a well-written project will spend about half of the time writing tests. Okay? But the good news is that this will speed up iterations because you won't have to go back and manually test all the features in iteration 1. You just press a button. And in fact, you'll do this on every commit. So you'll know in the middle of iteration 5 that you're breaking something from iteration 3, which is actually very, very good thing to know. Okay, so that's it. Until